Today we are going to talk about cluster analysis, which is one of the most important unsupervised learning technique of machine learning. Clustering is the process of dividing the datasets into groups consisting of similar data points. Let's take for example, people dining in a restaurant. People of the same family or people working in the same organizations tend to sit or dine together in a single table. So this is an example of clustering. There are different types of clustering. The first one is exclusive clustering, overlapping clustering, hierarchical clustering, and density-based clustering. We're going to see a little more on the exclusive clustering, which is also called hard clustering. It is also called hard clustering because the data points or items belongs exclusively to one cluster. One of the techniques under this is the Kmeans clustering, which we are going to see with examples. Here K stands for the number of clusters we need. Let's take an example that you have a pile of clothes and you wish to wash them. If the clothes belongs to different varieties, then you would wish to classify them depending on their colors, the type of clothes, and you tend to wash them separately. The flowchart, this is the flowchart of the technique. We need to specify the number of clusters, the value of k. Then depending on those values, we would initiate the value of the centroid. The remaining data points with respect to this centroid, we will find distance. Based on the distance, selecting the minimum one, we will classify them or group them into those many clusters. We would check if the group move or if the centroid changes. If no, then we have come to an end. Else, we continue by updating the centroid, the process continue. Let's take one example. Before we move on to the example, so we are left with three steps. The first one is determine the centroid. Second one is to update the distance and make groups based on the minimum distance. Let's take an example where we have collection of papers, and depending on the acid durability or strength, we would like to classify these papers. For example, there are, let's say, paper A, B, C, D, E. When we plot these 5 objects, then we have this graph. So let us take the first 2 points, A and B, as the centroids. These are taken just randomly. So the first step says initiate the value of centroids. So the value of C1 is 1, 1. That is the point of A, where and C2 has got the coordinate 2, 1. Now we need to find distance between the objects and the centroids. So C1 is one of the centroid, C2 another one. We have points A, B, C, D, E. These are the coordinates of the points. We need to find distance between each of this point A from centroid C1 as well as centroid C2, and that will form the matrix D1. For example, if we want to find out distance of E with 6, 3 from the centroid C2, then we have the Euclidean distance being calculated, and we evaluate to 3.61. Likewise, we find distance of all these points from the centroids. Once the distance are calculated, this is the distance matrix that we have just calculated. We need to find groups or clusters depending on the minimum distance. For example, A's distance from C1 is 0, whereas A's distance from C2 is 2.8, So we take the minimum distance and assign A to cluster 1 or group 1, and we represent by 1. So 1 0, indicating that A belongs to group 1. Similarly, all these points belongs to group 2, and we have two clusters at this point. We move on to iteration 2, where we update the centroid. The first cluster consists of a single point, and it continues to be as it is. And C2, the centroid, has got 3.75 and 2.5 as the coordinate. They are taken as the average of all the x values and the y values respectively. Then we find the distance matrix. The points A, B, C, D, E and centroids are used here. And we also update the groups depending on the minimum distance. So as you can see here, in the first cluster, in this case, we have 2 objects, and in the second cluster we have 3 objects. When we plot this, we have this graph, 2 points of first clusters and 3 points of the second cluster. When we update the centroid, we have the coordinate 4.33, 2.67 here, and 1.5, 2.5 for the first cluster. Now we need to find distance between these points and the cluster centers. Then further we see the groupings, and we find that A's distance is minimum with first clusters, B's distance is minimum with second cluster, C's distance is minimum with first clusters. So these 3 points A, B, C would belong to first cluster or group 1, whereas D and E would continue to have to be in the second group or second clusters. We update the centroids. Now, since there are 3 points of the first clusters, the centroid has been updated to 2, 2, whereas for second cluster we have 2 points and the centroid is updated to 5, 3.5. Now we need to find distance again. So after calculating the distance, we move on to find the groups, and we see that first cluster has got 1, 2, 3 objects, and centroid 2 continues to have 2 objects. Thus, when we update to move on to the next iterations, we still see that there is no change with the centroids, and hence, since the centroids do not change, we need not work further, and this is the 2 final clusters we have. We will see an implementation of Kmeans clustering in our next video. Thank you for watching.